Faster you start, the faster it's over.
Well, that is true.
That is true.
Sometimes, but I do talk a lot, so that's not always the case. I know. It is.
That is me being nice.
It is kind of my job to talk. Like it's what
I know.
like everyone pays me to do. So
I don't pay you.
it's not like but your parents pay me, so
That is
through
true.
default. Well, let's not get into all that. Your guardians pay taxes towards the school district, and so through some means or another, your people pay for all of us to be here and to do this. So yes, so today we're gonna go through the different spheres of the Earth and talk about that different. Close your Chromebook back there. I see that light. Yeah, got the light shining on your face. Yeah, we can talk about the flatness of Earth's spheres, and you can go through it about that way. But so listen, now that we have lots of different spheres, and we kind of take all the stuff that's going on the Earth and chop it up into different sections that we look at. Hey, everybody, make sure your head's up in the back. Wake him up. Yeah, come on. So we've heard of a lot of these. The hydrosphere is the water. The geosphere is the Earth or the rocks. But we have all sorts of different things that maybe you haven't really thought about before. We have the cryosphere, which is the frozen stuff. The atmosphere, which we all talk about all the time, and weather. You have the magnetosphere, which is the Earth's magnetic field. There you go. I was trying not to say sphere again. But yeah, your magnetosphere, there's all sorts of stuff going on. So we're just going to go down the page and kind of talk about what they have here. We'll watch a couple videos, not a lot, and we'll have a good understanding of the spheres. So we're going to start off with, and we haven't talked about plate tectonics yet. That might be coming up soon at some point. I don't know exactly when we go over plate tectonics, but we're going to start with the geosphere, which is all of the rocks on the Earth's surface. So we have a couple different terms for these. We're all familiar with the crust and the mantle and the core. Hey, put that down where he doesn't need to. He needs to pay attention to what's going on.
It's science.
How about you put your
How does this
Chromebook?
work?
Hey, put your Chromebook underneath your desk. We'll all wait for you, and we'll just drag this out even longer.
Take your time.
Thank you. Appreciate that. Wonderful. Now, let's focus a little bit. So, we have two different parts of this. When we talk about the crust, which is the outermost part of the Earth's geosphere, we have the asthenosphere and the lithosphere. The asthenosphere is kind of melted. The lithosphere is the hard actual crust that we think of at the surface. What the asthenosphere does is it allows your crustal plates, when we talk about plate tectonics and how they move around the surface of the Earth, I kind of equate it this way. The asthenosphere is like the slip and slide that allows the continents to move around. When we talk about plate tectonics and we talk about how North America is literally moving over towards Asia and Russia, and if you fast forward through many hundreds of millions of years, we will eventually connect and all become like one giant continent. How do we move in that way? How do the continents kind of float over to different areas of the Earth? The asthenosphere is part of that. It's semi-molten. It's kind of plastic-like, and so each of these continents kind of is able to be buoyant and slide around on top of the asthenosphere. Yes.
Do we have like samples of that stuff? Like, is it possible to get samples?
From the asthenosphere, no, we can't drill that deep. It's too much pressure and too much heat. We can get somewhat close depending on where you're drilling, but no, not down into the asthenosphere.
We've never actually seen it. We just know.
We've seen it. We haven't brought it to the surface and held it in our hands, but we've seen it through seismic waves and through how we see the earthquake waves travel through the Earth and interpret those.
So what's like the consistency?
It's more dense. It's almost like a semi-molten plastic. Is the consistency of it. It's not plastic. It's rock, but it's in this weird phase that's not quite fully fluid and melted, but almost like a thick honey kind of. And it's highly pressurized. It's got like the entire continent sitting on top of it. So it's not going to be the same consistency if you even were to bring it up to the surface. It would cool down and just be a regular rock.
Whenever our plates
like do collide into Asia and Russia, will they keep trying to go that way, or like everything stopping?
Yeah, no, they will. And what will happen is when they collide, it's going to be like a car crash, like a head-on car crash. It's going to crumple, and that's where you get your mountains. And so that's at some point, yeah, they will not continue to push into each other. They will stop. Whether they tear apart and go the other way depends on convection currents in the mantle. And so sometimes they do tear apart and separate again. Sometimes they don't. And we might get to that when we talk about plate tectonics. We can see old mountain ranges that are on different sides of the ocean because they hit and then separated back again. And so it's a crazy thing to talk about and think about plate tectonics and how like the continents move around. But there's lots and lots and lots of different types of evidence to support that. And so it's relatively not relatively, it's very accepted now. So we talked about the lithosphere and the asthenosphere. That's just at the surface, the crust. So you have the mantle, which is not melted, it's solid, but it moves around in convection currents. The hot stuff rises, the cold stuff sinks down to the bottom. And right in between the crust and the mantle, you have that asthenosphere layer that is like semi-molten and allows everything to kind of move around.
Is ocean crust and like regular crust different?
Continental crust and oceanic crust?
Yes.
No. Yes, they are different. They're not the same. Oceanic crust is more dense. It has darker rocks. And continental crust is more light in density and lighter colored rocks. And so the continental crust floats, which is why the continents are really old. When you look at ages, all the continents are like at least 3.5 billion years old. You can find rocks on every single continent that's like 3.5 billion years old. The oldest oceanic crust that you can find anywhere in any of the oceans is no older than 200 million years old. And so all the oceans are really young because they get pushed down and recycled. The continents are the same continents we've had since almost the very beginning. And so we have a lot older rocks there. So they're going to talk about temperature and geothermal gradient. Obviously, the stuff at the surface is going to be much, much cooler than the stuff further down inside the earth. As you get towards the core, your temperature gets up to like 5,000 degrees Celsius. Where here at the surface, a nice 70-degree day is like 25 degrees Celsius, 70, 75, maybe 80. I don't know. We don't use Celsius, but I'm getting closer to understanding that conversion a little bit. So they're just showing you your temperature here. Obviously, at the surface or just below the ocean, you're going to have a very cold temperature. As you get deeper and deeper and deeper, your temperature is going to go up, which is why we can't drill that deep. At a certain point, all our instrumentation, all our drill bits just melt away. And you can keep going deeper, but for every so and so many meters, you have to pull everything back out and replace all your equipment and put it back down in. But you can look up the deepest hole ever drilled into the crust, and it's like
14 miles.
I don't know. We Googled it. I'll Google it in a second. It's not 14 miles. It's like maybe 16 kilometers, which is going to be less than 14 miles. But yeah, I don't know if it was in the video or not, but it's capped off now. But I don't know. It's pretty deep. It's really deep. But
not very deep compared to how big the Earth is.
Yeah, no, like not even through the skin.
Yeah.
Not at all. So the hydrosphere is going to be all the water, including the cryosphere. So remember, cryosphere is your frozen water. It's kind of a subsection of the hydrosphere. So that includes everything from water in the oceans, water in the streams and lakes, the fresh water, water in the atmosphere, which is actually more water than you would think. It rains a lot, and before it rains, all that water's up there in the atmosphere.
The poles, like Antarctica and stuff.
Yeah, that's part of your cryosphere. So that's going to be like your frozen water. Yeah. In the ocean, they talk about salinity. It's talked about in parts per thousand. So, in fresh water, you have very little dissolved solids. Parts per thousand is 0.5. So if I have like 1,000 grams of fresh water, less than half of a gram is actually going to be dissolved substances. 99.95% is going to be actual H2O. When you get into ocean water, it's like 30 to 50. So roughly like 3.5 to 5% of ocean water is dissolved salts and other materials. I mentioned this in dual credit today, so I'll go ahead and tell y'all. There's a lot of dissolved gold in the ocean, more than you would think. It's like a crazy amount of dissolved gold in the ocean. We can't get it out because gold is non-magnetic, and you could use like a chemical process, but it would cost too much by the time you actually got it out. So just something to think about. Maybe one day you'll figure out how to pull gold out of the ocean. So here's your hydrologic cycle. You have rain, you have your water in the atmosphere, you have water in streams and lakes and creeks, and then your water in the ocean, and then also your groundwater that's seeped down below that's in the water table. So it kind of encompasses all of that. Then you get to your cryosphere, your frozen ice, your ice sheets, your icebergs, your ice frozen at the top of mountain ranges, and even in the ground, like your frozen tundra up in Canada. There's water below the surface that's just permanently frozen into the ground there. So they do have that. Let's see. Salt water now. They're going to talk about most of the water on the earth is salt water. So salt water accounts for 97% of water on the planet. Most of it's found in the oceans. You can find pretty much all elements in the water. Like I said, pretty much everything is dissolved in there. The vast majority of it, like I think 80-something%, is going to be actual salt, sodium chloride. You do have sulfates in there, magnesium, calcium, potassium, all sorts of other little things in very, very trace amounts. Because if it's on the continents, it's going to get dissolved by water. It's going to get kind of funneled down into the oceans through the streams and the lakes and the rivers, and it's going to end up there at some point. So here, they kind of show you the different dissolved things in the ocean. Like I said, 85% of it is sodium and chlorine. You have less and less and less as you go down the list, including some carbon. Anything else in there? Strontium. Strontium's radioactive. Fluoride, which we put in our drinking water to make our teeth nice and strong. But it happens naturally in the ocean, so not too bad. I know. You're going to get sick and die.
Wait, fluoride is natural?
Huh?
Fluoride is natural?
Yeah, it's an element.
Wasn't there like a big deal about the government like making fluoride or putting it in the water or something like that?
Yeah, that's what I just said. They do that. They do that everywhere. It's in all of the drinking water that comes out of the taps. It helps with your teeth and your
Right, but
bones.
is it? I know you just said it's natural, but have they also tried to man-made it?
Oh yeah, we don't like dig it out of the ground to put it in the drinking water. It's probably at least refined, if not manufactured in a chemical facility
That was like
somewhere.
a big deal that like they put like stuff like conspiracy theories were saying they put stuff in the floor.
Oh yeah. I'm sure, but it's just fluoride. They also put a small amount of chlorine in there to keep it from
I didn't know it
like
was
going
natural.
bad. But yeah, fluoride's like a natural thing. It's not like a man-made chemical. But the stuff they put in the drinking water probably comes from a chemical plant somewhere. It's not in there already. Let's see what this is. This is only 3.5 minutes. It's going to talk about composition of the ocean.
That covers about 70% of the planet's surface. And oceanography is the scientific study of these oceans. Scientists say oceans were actually formed long before land masses evolved on Earth's surface. More than 4 billion years ago, they believe, water vapor from volcanic action on the still young planet may have condensed into rain, gradually filling low surface areas that over millions of years became ocean basins. From the early beginning, oceans have played a crucial part in the formation and development of the world we live in.
In this program, we'll first discuss what ocean water is, its composition. Then, take a look at the...
That's terrible. We're not watching this. Sorry. Yeah, it's not going to be good.
Oceanography.
What is the ocean?
Yes.
Water.
It is salt water.
Water doesn't take its fish.
Hey, some of us, has everybody been to the ocean? Some of us have never been to the ocean. I have, but it's not like a nice
Do you like
ocean.
surfing, Mr. Dude?
Oh, I don't think I have the coordination or like the core strength to
It's
be
pretty
surfing.
hard. I love surfing.
Yeah, I'm sure it's nice.
Let's go shred some
If you wanna surf on the cryosphere, I've also never been snowing or skiing or snowboarding.
I've never been snowboarding.
Yeah,
I've been
yeah.
snowboarding there.
Let's be honest, skiing and snowboarding is a rich man's game.
I snowboard with my old skateboards.
Well, that's nice.
Take the trucks and the wheels off.
Is it like connected to your feet? Are you doing it around here or like up in the mountains?
Well, okay, in Tennessee. because
Okay,
they
okay.
get- I think there's a little more snow.
Okay.
Just duct tape it to your feet and you put stuff on the bottom to make it like slippery,
Yeah.
and then you just go down.
There's definitely a lot more snow in Tennessee. Even just up in Oklahoma, they get snow like several times a year where we don't get it hardly ever.
We get like once every like 10 years.
Yeah, it's terrible down here. I know. We need snow days. Snow days are the best days off of school because you don't know about it beforehand. You wake up in the morning and they're like, oh, you don't have to go to school or work today. Done. And it's just so much better than like if you knew all week, like you wouldn't have to go into school Monday. It's all right. Like you got a
You
day
like
off.
prepare yourself for it, but like
Yes.
if it just hits you, you're like, it's amazing.
Yes, it is real
And then you
nice.
get to
Yeah.
sit in the house all day.
And
drinking
you're like
cocoa.
sitting there watching the news and like you're waiting for your school to scroll by, and when you see like the pump, yes, snow day. It's so exciting. We need more snow days. We just need to like manufacture.
we get a
Wake him
little
up.
snow and they're like stay at home. But places that get snow.
No, ours there could be
Most
ice.
people
on the
Wait,
thing.
don't thump him on the head, but wake up.
Like
Alright.
other places get like feet of snow and they're like, yeah, make sure you wear your chains today.
Okay, so now we get into freshwater. Freshwater is mostly going to be
Fish.
well, yeah, where you can fish at. But freshwater is just the 3% of the remaining water. They said 97% is saltwater, only 3% is freshwater. However, about 69% of this freshwater is trapped in glaciers and ice sheets in Antarctica and Greenland, which is why we charge so much for water. When you get your own place and you take showers and baths and your water bill's like super high, you're gonna be like, this is ridiculous how much money I pay for water. But that's what it is. About 30% of it is groundwater, in which case if we want the groundwater out, we've got to drill for it and have pumps that pull it out. I will say in Texas, the vast majority of our drinking water and water supply comes from lakes. Most of the lakes in Texas are man-made. They've been dammed up for that specific reason, is to give us more water to use as drinking water and municipal water. It says about 1% of Earth's fresh water is surface water found in streams, lakes, ponds, ice, and snow. They talk about streams and rivers a little bit and some ponds, which we don't have to go deep into. They do have a 5-minute video on freshwater, which we'll see. I might check that out at the end, but yeah, I don't think we're going to do that. Then we get into atmosphere. Atmosphere is going to hold actually quite a bit of water, but they're talking about it just as the atmosphere itself. So your weather-producing sphere of air that we have. What's the most common element in the atmosphere? Nitrogen. And nitrogen is actually really important. If we have too much oxygen, that's bad for us.
We can
yeah.
breathe too much.
You literally can. It's called hyperventilating. And when you hyperventilate, what do? You breathe into a bag. Like, you ever seen the people like breathe into the paper bag? They're literally hyperventilating. They're freaking out and breathing too much. They're getting too much oxygen into their body, which makes them feel weird and freak out even more.
Humans are
So
weak.
you breathe into the bag, and what is happening if you're breathing in and out of the bag?
We need
Getting
carbon
carbon
dioxide.
You're
dioxide,
just-
not oxygen.
You're just breathing your air back in. So it has less oxygen, and more carbon dioxide is not necessarily great for you, but it brings your oxygen levels down. And so, yes, even too much oxygen is bad. Nitrogen is perfect because it's not bad for us. It's like an inert gas. And so if we breathe in a bunch of nitrogen, the atmosphere is like 60, 70 something percent nitrogen. 78% nitrogen. Only 20.1% oxygen. So all of that nitrogen that we breathe in all the time doesn't really do anything. It just goes in and out. It's not a big deal. So we do have some other trace gases in the air. They have nitrogen. Oxygen is about 21%. Water vapor, less than 4%, but still higher than most other things. You have your noble gases, argon, neon, some of the other ones, helium, inert gases. Carbon dioxide depends on what kind of time frame of the Earth's history that you're at. You could have really high carbon dioxide in the very beginning. We talked about that in the Earth's history section. how the atmosphere is mostly carbon dioxide. Now it's a lot lower, which is good for us. You also have some other different things mixed in here, methane. We're working on big centers to pull methane out of the air for use as a fuel. And then you get into the biosphere, which we don't talk a whole lot about here in Earth and space, but it's more of the biology area. All the living things on the Earth, all the plants, all the animals, all the microscopic organisms and fungi and all these other things.
Things that breathe.
Yeah, things that breathe and eat and use resources and multiply and take up all the space on the Earth. Then we get to Earth's magnetic field, which is actually very important. As we get better and better at space travel, when we talk about having human civilizations on like the moon or Mars, one of the problems is they don't have a magnetic field there, and it's very dangerous for humans to live there. The first humans that like live on that Mars colony will probably die from like cancer, high exposure to radiation. Even if we do things to try to protect them. One of the things they were really worried about sending people to the moon. The first time we sent people to the moon, they have to pass through a pretty intense radiation belt. And they were worried about whether the astronauts would survive that or what kind of effect that would have on them because we'd never actually sent people out that far. And so this magnetic field, and you can see that it kind of like bows out this way because we are moving in one direction in space. We are circling around the sun, but that sun is moving in a specific direction around space. And so our magnetic field pushes out in front of us, but towards the backside, it kind of gets dragged along, almost like a boat wake in a way. And so we have this kind of thing protecting us from the sun's electromagnetic energy and the radiation that's coming off from that. And that's very important to life being here. Mars used to have plate tectonics. It used to have big volcanoes. It doesn't have those anymore. And so it doesn't have a magnetosphere, which is why Mars's atmosphere essentially blew away. It has like 1% of the atmosphere that we have. If it had a magnetosphere, it might be more hospitable to life. Well, yeah, I'll make it quick. Thank you for stopping me in the middle of my magnetic talk here. Almost to the end. Actually, wait a second. We're almost to the end here. We're at the very bottom. You can wait just a minute. All right. So, forming the magnetic field, this basically comes from the core of the Earth. As you have these metals in your nickel and your iron in the core here, and the inner core and outer core, they're hot and they're circulating. And just like a fan that produces a magnetic field and pushes the blades around, it's producing that same magnetic field around Earth, and it's kind of got this circular pattern coming in and out, which is what leads us to, if you get radiation happening just in the right way, you get the northern lights happening. So you can see the magnetic field interacting with the sun's radiation and creating, please stop that, creating a nice visual effect. What? I can hear you burping from across the class. Oh, who was that?
That's this fool.
Stop burping. What's wrong with you? You're an adult. You can control that stuff. Man, if anybody ever watches these videos, they're going to be like, this classroom is a mess.
That's exactly what I said.
Yes. Sorry I accused you of burping, but it did sound like it was coming from that way. But thank you. All right. So I think that's it. Magnetic field. Yeah. Let's see. You can go ahead and go to the restroom now. Yeah, y'all can.
Is the Earth's magnetic field being blasted in 1997?
Oh, this
Massive gusts of wind.
is that Darth Vader? Yeah, I'm pretty sure that's him.
The normally calm field, shown here in gray, rocks violently as waves of particles strike.
No, what's his name? What's the guy who voiced Darth Vader? Yeah, James Earl Jones. That's totally James Earl Jones. Like, I promise you, that's totally James Earl Jones.
Blasts like these can knock out power grids. The wildly changing magnetic field acts like a dynamo,
I bet it
generating
is.
extra electricity in cables. Circuits trip or blow. Prevent 1989.
This morning, 6 million people across Quebec woke up to darkness and disbelief. People in Hydro-Quebec are not positive, but they think the blackout was caused by the sun.
The sun's coming for us.
Darkness for Montreal, but lights for the rest of America. The particles that knocked out Quebec made it down to Earth and set off the aurorae, the northern and southern lights. High-speed electrons cascade down Earth's magnetic field lines.
Whoa. The high-speed electrons
Like
came into
electricity making the gas in a neon light shine. They collide with the oxygen in our atmosphere, and it glows.
Okay, they're not going to talk about it, but this is actually a problem that we're kind of worried about, and we'll talk about this when we get to plate tectonics. The Earth's magnetic field flips every so often, and we're actually overdue for a flip. On average, it flips a lot sooner than it has in the last cycle. And so every time the poles start to move very quickly, all the scientists that study this are like, is this the flip? Are we about to see the flip? And what we don't know is, do the poles just flip like normal? Like you have the North Pole and the South Pole magnetically, and they just kind of turn around and flip? Or do they kind of stay in a weird position for a while, which would mess up all our satellites and mess up our communication? Or the worst case scenario, do they disappear and then come back in the reverse manner? If they disappear, we could spend like years or tens of years or hundreds of years or even more without a magnetic field, which would be really, really bad for life on Earth. And we don't yet know how that works or how that happens. Like, we don't have it preserved in the rock record. We have some of the movements, but it's difficult to kind of interpret.
How often do the flips happen?
It's been 1 million years since so some of them are very long, some of them are very short. But on average, it is a much shorter average than this current episode of positive polarity. So I don't know. And when that happens, if you're like a survivalist and you have a compass, your compass will now not point towards the North Pole; it'll point towards the South Pole. By the way, if anybody does that stuff, you should know that your compass doesn't point towards the actual North Pole. It points towards the magnetic North Pole. So if you go out and use your compass to find your way around, before you leave, you should look up the declination for the part of the country that you're in, and it'll tell you if you're pointed north, how many degrees to the left or right is the actual North Pole, is the actual north that you're trying to get to. Usually it's not that big of a deal, but if you're going over tens of miles, you might end up a mile or so down the road from where you thought you would be at. I don't know. It's a little cool. It's not cool. Yeah, I think that's about it. We're not going to watch that lake one, the freshwater.
That one looks weird and lame.
It looks really old. Let's see how.
It's 1942.
No, I'm thinking maybe 80s though.
It's so blue.
Fresh water does not have the dissolved
stop yelling
salts that
at
are in
me.
the world's oceans.
Screaming.
It's a precious resource.
Wrong way.
Humans
Sorry.
and most other animals can only drink fresh water, and plants need it to survive. We have long tried to control and conserve water. We dam up rivers for hydroelectric projects, divert water to irrigate crops, and build flood control projects. But many people in the world still suffer from a lack of fresh water. Starvation in the developing world almost always is related to prolonged drought. And even in the developed world,
Yeah, we're
there
not gonna
are
watch this. It is a problem though. If y'all ever had to boil your water, yeah, that just kind of puts into perspective how lucky we are to have the water systems that we have. When they're boil your water, and you have to either go out and buy bottled water or literally boil your water to use as drinking water. I don't know what time is it.
So we're about to leave for
Wait, what is this? Fourth period, 33.
Yeah.
Make it quick.